This is an Enphase system with 2 of the 10 Ts, the 10 thin batteries. Each one of those batteries is 10 kilowatt hours. This is like the first generation battery that Enphase came out with. There's three kilowatt hour batteries inside of each one of these. So they're like 3.3 kilowatt hours. So they add up to about 10 kilowatt hours each. Each one of these batteries outputs 16 amps continuous. And so each one of these is fed to 20 amp breakers. So here's what we call our battery load combiner panel. It's just combining the 2 battery outputs into one feed. So I have battery 1, battery 2, each one's on a 20 amp breaker. The new 5P batteries are going to be a 20 amp breaker per 5 kilowatt hours. So it ups the amount of storage capacity for kW output. We have our output breaker. That output breaker then heads through a gutter. Gutter is really nice with these systems because you can really take all of your wires in and out and go where you need to go. It makes everything really nice and clean. So output of the battery comes over here and hooks into the storage terminals down low. Everything then aggregates up here. So you've got top left is the storage breaker, bottom right solar, top right is neutral forming transformer and IQ gateway, and then bottom right is the generator. So we have a Generac generator outside. Everything's aggregated through here, so the system controller is doing all the work. It's actually doing all the transfer switching, the neutral forming, everything. So right here we have our incoming lines from the main service. This is a partial home backup. So we're feeding the smart switch with the 100 amps. It actually feeds through the MID relay, which is this thing here. That's what turns the grid off and on, or basically transfers the grid off and on so it doesn't backfeed the grid. Output wires go to the backup loads panel. The backup loads panel is over here. Here's our backup load panel. So it's a 100 amp panel. We've got all of our circuits in there that are backed up. Lights, outlets here and there, furnace, things like that, you know, real essential things. So we're not backing up EV chargers, you know, ranges, anything like that. Just because you'll roast your batteries and there's not enough power to run it. There's our breaker that's feeding our system controller. So it feeds from the main, that's a 2.2, it's a 320 amp service with 2 2s. So the 100 amp feeds over to the system controller. There we go, system controller, MID relay through all the things. Output to the backup panel. Here's our generator input. You need 2 CTs that's in parallel with your consumption CTs. So essentially when grid's down and it calls for the generator will turn on and it reads it through the consumption CTs. We have our solar combiner. We got 3 strings. 3 strings of solar on the roof, IQ8A microinverters. We've got our cellular kit. And then this is going away, but there's the comms kit. It's actually, if you just take that black box, open it up, it's just a USB, so you can eliminate one point of failure. I don't know why they don't just ship it just like that, but you can plug it right in and it works great that way. The new 5C combiner boxes are all going to be hardwired, so that goes away completely, and then it's just going to be like a Modbus deal. Got my generator control. This is essentially for a Generac generator. The system controller outputs a 2-wire start signal, but Generac can't handle that. Generac's a grid sense. So essentially what we have here is we have one circuit for the battery charging, and then L1, L2 for your 240 volt signal coming from the backup loads panel. And then essentially what's happening is it's closing that contactor, which then powers that 12 volt power supply, which then powers this coil and says, hey, open up and turn off one of the legs, which simulates a grid outage to the Generac generator, and the Generac generator will turn on. So it can call upon that generator at any time, grid on, grid off. It can just call upon it by closing that contactor, and this little control box that I built is essentially simulating a grid outage. So there's the combiner box, system controller, everything is nice through the gutter. Battery combiner, batteries. Generators outside on the north side of the house. It just sits there and waits for the system controller to call on it. It's a air-cooled generator and doesn't really need much maintenance because it won't run that much. It's pretty much there to run loads and charge batteries if there's no solar. So that's it. It's a nice system. We're going to be having a Enphase 5P system coming up with the new third generation system controller and the 5C combiner, so look for that here soon. It's going to be the whole new deal, and we'll have full generator, 8 batteries, everything on that one, so that one's coming up here soon. But this is kind of the hard part, is getting that control and battery charging and all that good stuff. So all that is powered out of your backup loads panel, because the backup loads panel is running and the grid's out, and so we want to be able to charge the generator battery and do grid sense, turn off and on that generator, because we don't need it when the batteries and the solar are up. But when the batteries or the solar get low, you set critical set points for the generator. It'll then turn on that generator and use it to charge batteries, run loads, things like that. So it's a really nice, well-rounded system to have all 3 going on here: solar, batteries, and generator.